everybody, welcome back to Web Inspector, the semi-daily show for creative web developers. I am Timothy Miller, your host, and it's Friday, which means we're going to cut back a little bit and learn a little bit about game programming concepts through the lens of Pico 8. So I have another challenge for myself today. We're going to build it from scratch. Hopefully you'll enjoy your time here and learn a few things. Let's open up Pico 8. Here she is. And you can see in the background here, I've got an article about game cameras in two-dimensional games. So what I want to do today is I want to just build a collection of cameras that showcase some of the different ways that you can build cameras in 2D. I feel like this is a good way to kind of start thinking. I mean, a lot of programming is learning how to think properly about things. And building a bunch of two-dimensional game cameras, not only can it show you how simple some of these things are and what a big difference they can make, but it also gives you a new perspective on all of the games that you play. And you start thinking about those little details that you've never really thought about or noticed before. So yeah, so let's build some of these things. First of all, we need to build a scenario where we can actually see what's happening. And I'm just going to be lazy. I'll have a character. That'll just be a gray rectangle. And then I need some sort of a map. We'll just do white and peach. I'm gonna make this little grid, copy these cells. I'm just gonna do this just to make this super easy for myself. So there's our map. Now I'm thinking my character should be a brighter color instead of this gray. So let's make them blue. So now what we need to do, we need to start on our code. First, we're just going to want to draw the map. Let me pull up the documentation real quick. I haven't worked with Pico enough or consistently enough to remember all of these commands, but this is what I'm looking for, this map draw cells function. So I'll put that up there. So we want to do map. So there's our map. Now we need our character. And just to make this a little cleaner, I'm going to have a variable called player, which is very, very basic. And then we'll draw that player with the sprite function. Then we'll draw the character with the sprite function here. So sprite player dot sprite. I might not want to do this actually. We'll just do s. Player dot s. All right, so there's our player. Now we need some basic controls. For that, we're going to need the update function. And then we need some button presses. So if btn 0, btn p 0. I don't remember which directions everything are. So I'm just going to say y minus equal 1. I think these numbers like start at the top and then go around in a clockwise order. I think that's right, but I guess we'll find out here. Okay. Also, I don't want the button P function. Okay, so I've definitely got some directions mixed up, but right is correct. So x plus equals 1. Now there's one problem with that. Well, I mean, there are a few problems with this. One of the main problems is because I'm just adding 1 for each button press, when you go diagonally, it goes twice as fast, or it seems like it's going twice as fast because it's adding 1 to both x and y. So that's one potential problem with it, but for the moment, we're just worried about cameras. For that, I'm going to need a global variable, global equals, and then we'll do current cam. And so I'm trying to think of how best to do this. I want to be able to name these camera configurations and put their logic elsewhere, so that I can kind of keep everything in its own little box. Current cam is going to be the coordinates that I always use. So we'll do x equals 0, y equals 0, and then somewhere in this update function is where we will actually do the logic for this. So let's call g dot, and we'll just make this a function, g dot update cam, and we'll just call that. And let's just, for proof of concept, let's do update cam equals function end, and then in here we will do g.x equals player.x, g.y equals player.y. So we've got this function. All it does is it updates these to equal the same as this. And this should potentially give us the first camera that we're looking for, which I will show you here in a minute if it works. So update cam, we're calling that. And then we also need to draw the cam. So we want to draw the cam, or we want to use the cam after the map. No, I think we want to do the camera first. We'll find out here. Let's see if I can find the documentation for it. Yeah, so camera XY. It works. It works great. Camera, we'll just do G dot. I'm not loving this, so I'm just going to do cam. G dot cam. I forgot to do this. G dot cam.x, G dot cam.y. And then we'll do G dot cam.x, G dot cam.y. And we'll see what this looks like. So, all right. So that's kind of working. You can see we're getting some weirdness here where it's like smudging the screen almost at the edges of the screen. So that's interesting. And I know why it's doing that. It's because we're neglecting to clear the screen every time we do this. So clear screen is what we want to call at the beginning of that. And that way it's not like, it's not drawing, it's not leaving stuff on the screen every time. It's clearing it and then redrawing it. So there we go. So this is essentially the first camera that we're looking for, which is position locking. So Terraria, you can see the player is just locked in the middle of the screen. Right now the player is locked on the edge of the screen for us, but that's easy enough to fix. In our logic here, all we have to do is we have to add half of the screen. So we know the screen width and height is 128. So the quick and dirty way to do this is just to add 64 minus half the width of the character, which would be 4 pixels. So we just add, or actually we'd subtract 60 from each one of these. And there we go. There's our position locking. So there we are from scratch. We built the first type of camera, which is this position locking camera. But it's not very clean. It's not very pretty yet. We still have a little bit of work to do to make this a little more flexible. So we'll dive into that next. So there's position locking. I am going to take this logic. I'm going to cut it out of here. And I'm going to put this somewhere else. I'm going to say function position locking and paste that in there. And then I think what we can do is to make this the default function, we can just do position locking. Let's see if this works. That does not work. So we might need to move this whole function up so that it's above this, maybe. Okay, so that does work. I don't like this very much. So what we'll do instead of doing this is we'll do this in the initialization function. So we'll do g.update cam equals position locking. And then we can take this function and put it back down at the bottom where I like it better. All right, so there's our first bit of logic. A little bit cleaner way to do this rather than just doing -60 would be to take the width of the screen, half that, and then add to that half of the width of the player. But we don't have any of that stuff set up, and this is just kind of a proof of concept, quick and dirty way to do this. So we're going to ignore that for the time being and move on to the second camera, which is kind of this box type of camera. So camera window is what they call this, and it's got like a boundary area essentially where if your character gets within a certain width of the edge of the screen, then it moves the camera. Otherwise, it just leaves it alone. So you can see they've got some different size boxes for different things. Fez has an interesting one, but it allows your character to move as much as you want within your box, and it won't change the camera. It's good for some kinds of puzzle games, and I guess there are action games that uses it too, which surprises me a little bit. But we'll do that one next. So essentially what we want to do is we want to watch the player's position, And if the player gets within a certain boundary of the edge, then we change to make it so that they aren't so close to that edge. So this one's going to be a little bit more complicated. So we'll say if player.x is less than, so let's create a buffer variable, assuming that we just want a rectangle in the middle, and we'll say local buffer equals, we'll make it 24 pixels. So if player.x is less than, we're going to need to subtract it from the camera value, I think, because we want it from the left edge of the screen. So we'll do if player.x is less than g.cam.x plus buffer, I think that's what we want to do, then say g.cam.x equals player.x subtracted by the buffer. I think that'll work. Let's swap this function out for this one. Instead of starting with position locking, we will comment this out. For now, we will do g.updateCam equals window locking. Run that. Oh, nope, doesn't work. Camera window. Oops. Camera window. Run that. All right, so now the camera shouldn't do anything unless we get close to this left edge. Okay. All right, so now we just want to duplicate that logic for all the other different directions. Player.x is greater than g.cam.x plus 128 subtracted by the buffer. So we've got g.cam.x is the left edge of the window. Then we add 128 to make it the right edge, and then we subtract our buffer, and that should give us the right edge of our rectangle. And we do this again, g.cam.x equals, and we just basically reverse that logic. So player.x plus buffer. Then we do else if player.y is less than g.cam.y plus buffer. And this is the same logic that we just used, except for the y-axis instead of the x-axis. And we don't actually want an else there, but g.cam.y equals player.y subtracted by the buffer. And then else if player.y is greater than, and here's our last check, cam.y plus 128, so we get the bottom edge of the screen subtracted by the buffer. Then g.cam.y equals player.y plus the buffer. Is that right? That seems right. Let's run it. Syntax error, unclosed if. Else if. Oh, it doesn't actually have. Else if is just one word, isn't it? Else if. Okay, so right edge. That's not quite what I had in mind. We're setting this improperly. So we don't want to just do player.y.buffer or plus buffer. We want to reverse the logic we're using here. So g.cam.y, so we want player.y. Do we want to add 128? So what are we doing wrong here, guys? We're obviously setting the camera to the wrong value. So if player.x is greater than, so we've got the cam x, we're missing the cam x, that's what we're missing here. So I know what we're doing wrong here, guys. I wasn't thinking about the camera x value properly. So what we actually want to do here is the player.x, we want to add our buffer to that to get the right edge of the screen, and then we want to subtract the width of the screen to get our camera value. So plus buffer subtracted by 128. Let's just see if that works on the right side. I think that should work. Okay, yeah, so we've got our buffer there. We've got it on the left side. Now we just need to do that same logic down here. It's really easy to start to miss the forest for the trees when you're doing this sort of stuff and to get your arithmetic mixed up. So we add the buffer, we subtract the width of the screen, but you just have to think through it logically. I mean, game programming is a very logical pursuit. Oftentimes it doesn't require as much brainy mathematics as people think it does, but it does require a very logical thought process and thinking through every step and thinking through all of the different variables that you're working with here. So there's our second camera. Let's see if we can get through the third one. Third one is a type of horizontal snapping. So you snap to the right, and then you actually transition. You transition to kind of pull your character back to the middle as he moves up. So we don't have like a jump function with our character in our game. So it's going to be a little bit trickier to showcase this one, but I do want to show it so that we can kind of go through this transition principle that we have. Transitions are a little bit trickier in game programming. In web development, you can just say, hey, I want to transition this property, and the web browser takes care of it for you. In game programming, it's a little more difficult. Let's create a new function. Position snapping. First thing, the easy part is we just want to keep the x-axis locked on the player. So let's start with that. We will go g.cam.x equals player.x subtracted by 60. It's the same trick we used up here. Let's swap this out so that we can see what it's doing, make sure it's doing what I want it to. Swap that out right here, run. So yeah, it's locking to the x-axis. The y is not doing anything currently. So now the y value, what we want to do is we want to check if the y value is in the middle every frame. If it's not, we want to take it a step closer to being in the middle every frame. So it's actually not all that difficult. We will do if g.cam.y, do we want to do greater than or less than? I suppose we can do it that way. So if g.cam.y is less than player.y minus 60. So we're checking the top now. So if the camera y is less than the edge, so if this is true, if this statement is true, then the player is off center towards the top. So we want to add a little bit to the camera's y. So then g.cam.y. We'll just add a very small transition to start out with. We'll just do like 3 pixels. Plus equals 3. Actually, let's do 2. And then we do else if g.cam.y is greater than player.y plus 60. That's not what we want, is it? This feels a little janky. We'll see if it works. g.cam.y minus equals 2. And I haven't gone through any of these examples before, guys. I'm just learning on the fly here with you, which makes it exciting. Ooh, that's janky. So you can see it's working in one direction, but it's working too quickly. It doesn't have any sort of transition. So instead of like smoothly changing, we could try changing this by a smaller amount to make it less fast. And that kind of works, you can see, but it still feels a little janky. It's still not working in the other direction for some reason. Let's try player.y minus g.cam.y. We'll use kind of the same logic, is less than 64. Then we add, let's see if that works. Whoa, come back. Okay, so that's not working. I'm gonna try a different tactic with this, guys. So we also need these outer boundaries, right? Where if the player is going off screen, then we stop it and we just move the camera. So let's set up those outer boundaries first. We'll go if player.y is less than g.cam.y plus, let's give it like an 8 pixel barrier. Actually, let's just do 16 pixel barrier on the edge. So that's this little edge part here. If it's less than that, then we just set player.y to g.cam.y plus 16. Player.y is greater than g.cam.y plus 128, and then we subtract 16 is equal to g.cam.y plus 128 minus 16. So that should give us that buffer where if we go off, then it just stops us, stopping me from moving after that, which is not what I want. I actually want, instead of changing the player.y, I want to change the camera.y. Player.y subtracted by 16. So we add 16 and then subtract 128. So right now this is just the same kind of window locking we did before, except it's a really tall, skinny rectangle. What we still need is that easing, where we check if it's not on center and kind of ease it back up to where we want to be. All right, so we want to do this easing thing. And there are a number of different ways we can do this. I'm just going to do a quick and dirty way. I know there are better ways to do this, but this is the way I'm going to do it for now. I mean, we're just having fun here. We're learning things, and there's no fancy easing methods in Pico 8. We just kind of have to build all this stuff ourselves. So we're going to just do it the simplest way we can. So first we want to check if the player is in the middle. What I'm going to try checking if he is above the middle first. And if he's above the middle, I'm just going to pull the camera up a little bit. And then I'm going to check if he's below middle. And if he's below middle, then I'll just pull. So we're just kind of doing this double checking from each direction and acting appropriately. So player.x, we want to check if he is above the middle first. That means he's above the middle, which means we want the camera to go up. So we'll subtract a little bit from g.cam.y minus equals 1. Then we'll try to do the reverse. We'll see if it works. I don't think this is going to look good, but we'll see if it works. Hey. Okay, so you can see it kind of transitioned up in the first place, but now it's just like position locking. It's just locked because the amount that the camera is moving is actually the same as the amount that our character is moving. The speeds are the same, so you get none of that transitioning. So if we do like 0.2, I'm not sure how Pico will deal with this, but we will see. Ooh, that's pretty rough. So we obviously want it to happen faster than that. And we really don't want that to happen. One problem is it's doing this thing. It doesn't actually stop when it's exactly in the middle. The other problem is it's just super laggy and jerky. So one way we could fix this that would be a little bit easier is just to switch it back to 1 pixel at a time. We move it 1 pixel at a time, and then the player needs more speed. So if we come back up here, we'll do, let's just add a speed variable to the player. 2, we'll just make him go 2 for the moment. Player.speed. All right, so that already feels better. So the character's moving faster. You can see it's locked when it's going like this, but otherwise it's just kind of slowly transitioning back to the center. It would be a little bit more of an obvious effect if we actually had like a jump mechanic like they do in this game, where you're able to go up faster. But that is the basics of how this camera works. So guys, there's 3 basic ways to do a game camera for a 2-dimensional game in Pico 8. We can go through more of these if you want, or we can stick with this. I'm happy either way. I will upload the code for this onto the Pico Challenges repository so that you can see everything that I've done. And if I decide to make any more of these, you'll be able to see those there as well. All links will be in the description below. So I had fun doing this, guys. I messed up a few times. It was pretty sloppy and clumsy and all of that stuff, but I hope you learned a few things here and there with me on this journey. Thanks for joining me for a little bit of fun on a Game Day Friday, and we will do this again next week. Thanks for joining us. Remember, guys, never stop learning. Bye.